go. All right. Today's date is January 30th, 2020. Wow, okay. The objective, what we want to do today is talk about rational exponents. And the word rational just means fraction. Okay? So, a rational exponent is some base to some m over n, and the rational exponent is that. It's a fraction. The exponent is just a fraction, so we know that the exponent is a fraction. In exponential form, then, we can write it as base to the mn, and we can rewrite it in radical form. We can change it to the nth root of b to the m. Or we can start in radical form and change it to exponential form. Or we could say that we've got some nth root of b to the m can be rewritten as b to the mn. Okay? Same thing. One is one version of it, and the other is another version. Okay? The example I like to use, which I think is the easiest, is that 8 to the 2/3 power. Now, Austin, or somebody said 7. Somebody said 7/3. That was you, right? So if it's not a perfect root, you just have to use a calculator and get a decimal answer. Does that make sense? It's a nice one like this one. We know what the cube root of 8 is 3, right? So if it's one you can do your head, you may as well. So I like this example because I can go straight to the cube root of 8 squared. Here's my root and my power. There's my root and my power. Okay, so I've got my root and my power. Okay? So example 1, all we're going to do is change it. We're not going to go ahead and get any weird answer, but we're just going to change from one form to the other. Okay? We're not going to get an answer. We're just going to change its form. Okay? Rally, question.
We've already covered this, but what if the power is higher than the root?
That's okay. It really is. That's okay. Just means our answer would be more than the original, right? So I'm going to change this. This is going to be 7 to the 2/3 power. Okay? All I want to do is change it. I want you to get used to going from one form to the other. Now, we haven't done an answer. There is no answer. We're just going to change it from a root form, power, and root. Thumbs up? Okay. Second example has an invisible 2 right here. You guys agree? And an invisible 1 right there. Okay? So we'll rewrite this as 5 to the 1/2 power. Now I want to give you a rule that needs to be in your notes, or at least in your notebook, and that is this. You will see this all the way through calculus and beyond. Anytime you see the square root of any number, you can rewrite it as a 1/2 power. Okay? And you're going to see that a lot. And we just did it, didn't we? We just did it. We had a square root because we know there's an invisible 2 here. We know there's an invisible 1 here. Okay? You will, if you take a lot of math, you're going to see this a ton. Okay? But it's pretty simple, isn't it? Okay? Okay, 6. Let's go the other way. So 1/2 is a square root. You guys agree with that? 1/2 is square root power, so it's just square root of 6. If you want to put the invisible numbers in, you can. But with square root, it's always implied. It's always implied that that's a 2. We don't write it because we know it's a 2, correct? Okay. On second one, we're going to go the 4th root of negative 2 to the 3rd power. Okay, I'm just going to transpose it. There's my root, and there's my power, right? How am I doing? Thumbs up. Okay, return the page. Now, example 3, we're going to evaluate. So, I'm going to give you some really good advice on these. Take the root first. It can be done 2 ways. I could go, what's 27 squared? I don't know. And then I get this big number. And then I got to take the cube root of it. head's hurting. Or, let's just make it easy. What's the cube root of 27? 3 to the second power is? Isn't that much faster than going, 27 squared? But if you reduce it first, take the root first, it gets easy. You can do this in your head. The cube root of 27 is 3, because what times what times what makes 27? I still have to square it, but that's 9. If I did it the hard way, which I could say, okay, what is 27? Hold on, clear. Quit. If I go 27 squared, I get an answer of 729, and I need the cube root of that, and, well, let's see, that's got to be 9, right? That's the hard way. Don't do it the hard way. Okay, let's take a look at the second one, 32. That's the 5th root of 32 squared. You okay with that? There's my root, and there's my power. Again, I could go 32 squared. Don't. But I could say what's easier, let's do the root first. Okay, so you ready? What times what times what times what times what makes, yeah, there you go, makes 32. It is, everybody agree with 2? Everybody agree with 2? Okay, so I've got a 2 to the second power, which is 4, okay?
Now,
Example 4, okay? So, with example 4, okay, if the square root of x is a 1/2 power, right? Then a cube root should be what? What do you think? A cube root should be a 1/3 power, right? So a cube root of x, is a 1/3 power. Now, to do example 4, I am going to do the cube root of 64. That's what it says. So again, it's not that hard. What times what times what makes 64? Kai says 4. You guys agree with that? Okay. So I'm going to go to 4. So I've got the cube root of 64 is 4. Now, I'm going to take x to the 6 and take 1/3 of it. Because I'm taking exponents, right? X to the 2. I'm going to take a y to the negative 12, and I'm going to take 1/3 of it. Y to the negative 4, okay? There's one more thing I can do, right? Let's fix the negative exponent. So, 4x squared over y to the 4th. Okay, how's that? You didn't take notes. It's all right there, huh?
yeah.
Okay, good. All right, hope so. All right, so homework.